Algebra 2 Builder number 2. We're going to go over these problems, and the first one here is solve equations. We have 5x minus 1/5 equals 2x minus 3/5. There are a lot of different ways to do this problem. The thing that I would like to do is get rid of these fractions. And in the denominator of each of these fractions, 1/5 and 3/5 is 5. And so what I'm going to do is clear out that denominator by multiplying the entire equation by 5, both sides. And so we have 5 times 5x is going to be 25x. Then we have minus 1/5, and we're multiplying that by 5. And then equals, we have 2x times 5, excuse me. And then we have minus 3/5 times 5. And I hope you can see that these 5 over 5 will cancel, 5 over 5 cancel, and what we have left is 25x, and we have minus 1 is equal to 10x minus 3. And what I want to do is accumulate all the variables on one side and all the numbers on the other side. So I'm going to subtract 10x from both sides of this equation. And I'm also going to add 1 to both sides of this equation. And what that does, on the left side we cancel out that negative 1 plus 1. On the right side we cancel that 10x minus x. And what we have left is 15x is equal to negative 3 plus 1, which is negative 2, and we divide by 15. We have, when it comes to the right here, we have x is equal to negative 2/15. So that is going to be our correct answer for this first one. Next, solve inequalities. Solve, show your answer graphically with set, builder, and interval notation. So it's like solving an equation, pretty much, except possibly for one thing. So we have this minus quantity 4x plus 3, so we distribute that negative sign inside the parentheses. So we get 2 minus 4x minus 3 is greater than or equal to 7. And next we can combine like terms, and to do that, on the left side we just have 2 minus 3, so we have negative 4x, and 2 minus 3 is minus 1, and that's going to be greater than or equal to 7. Next we're going to add 1 to both sides. So we have is negative 4x is greater than or equal to 7 plus 1, which is 8. And so I'm going to bring this up here to the upper right. So we have negative 4x is greater than or equal to 8. Next we're going to divide by negative 4. Divide by negative 4. And then what we have is x is, and then the right side we have 8 divided by negative 4, which is negative 2. And so is it going to be this? Is that going to be it? Question mark. Is that going to be it? No, it's not. We divided by a negative number, so what we have to do is we have to reverse the direction of the inequality. So what we're going to get is x is less than or equal to negative 2, and it says graphically with set, builder, and interval notation. So what we're going to do is, for set builder, we're going to do it like this: x such that x is less than or equal to negative 2, and then what we have is interval notation is we have greater than negative infinity to less than or equal to -2. It's going to be a bracket. Now I want to do one last thing, because if this is correct, then I'm going to test one to make sure that it's right. I'm going to try 0, okay? If we try 0, it should not work, because we should get less than -2. So we plug in 0, we're going to have 2 minus 3. Well, is that going to be greater than 7? No, that's less. So, and we could try one that actually works, but that's going to be our answer in set and in interval notation. Oh, wait a second. It says graphically. Oh, I forgot graphically. Let's go back to graphically. Okay, graphically, we go ahead and set at -2, and graphically it's less than or equal to, so it'll be like this, and then to the left like this. So that is a graphical representation. All right, now we're ready to go on. Next, evaluate expressions. X squared minus 3x plus 5 when x is equal to -2. What we're going to do is take every place in our equation where we see x and substitute in for it -2. And the trickiest one is this x squared, because what we need to do is take this -2 and place it fully within parentheses. And then we take this 3 and I put open parentheses -2. And especially where you're working with negative numbers like we are here for evaluative purposes, I highly recommend putting a parentheses in place and just placing the value where those parentheses are, because that minimizes the chance you could make a mistake. Okay, now -2 squared is going to be 4, and then we have minus 3 times -2. Well, those are going to be positive, negative times negative, so it's going to be plus 6, and then finally bring down the plus 5. So our answer for this evaluation is going to be 15. Next, literal equations. M equals MOL over L. We're going to solve for MOL, and then what we're going to do is we're going to cross multiply this L on the other side, and so what we get is mole is going to be equal to ML. And one way you could look at it, if you look at it another way, I'm just going to rewrite it over here. It's like you're multiplying this whole equation by L. And so on the left side you get ML, and on the right side you get mole divided by L times L. They cancel each other, so we end up with the same answer here. And that's that one literal equation. Next, relations, functions. Determine if the relation is a function, find the domain and range. And what you're looking for is a vertical line test. A point above another means it cannot be a function. Hope you remember that song. So I'm going to do is create a vertical line. I wish I could do a vertical line. Let me see if I can do a little bit more. Drawing this freehand can be challenging. Okay, that's about as good as I can do. So I'm going to take this and move it to see if this thing touches the function more than once. No, doesn't touch. So we don't have a point above another. So as far as being a function on this, I think we're in good shape. So yes, a function. Pass the vertical line test. Domain. Well, domain would be x values. We have x, y. So I'm going to put in set notation x equals, and what I find that for individual values, the set notation is really quite helpful. And so we look at for the x values starting from lowest to highest, and it looks like we have at x equals -1, -2, -3, -4, -5, -6. It's kind of small. So we start out at -6, and next x value over to the right is going to be -5. Next one to the right is going to be -3. Then next one to the right after that is going to be 2. So comma 2. And then we have comma 4. Then comma 5. Then I'm going to bracket this off at the end. 4, 5. Okay. And then range is going to be the y values here. Well, let's see, we're going to start y equals, similar type of notation. And I'm going to start here. Looks like we have the lowest value, -1, 2, 3, 4, 5. So -5. And then we go up to the x-axis. So that's going to be 0. And then we have 2, 3, let's see, 2, 3, 4, I think. Yeah, 2, 3, 4. Now I will tell you a common mistake I see in a situation like this. Sometimes I see people want to write down like an interval notation like x, x is going to be greater than or equal to -6. That's in inequality, and less than or equal to 5. And then similarly, y is greater than or equal to -5 and less than or equal to 4. Why is this incorrect here? Well, the reason this inequality notation is incorrect is because this would include, for instance, x equals 0. Well, x equals 0 is not part of the domain. The domain is only where the x values exist. So this type of solution set is wrong, and these ones that I wrote up here are correct. Next. Word problems. Harry works for a major sporting goods distributor. He earns a base salary of $30,000 per year and a 5% commission on his sales. How much will Harry need to sell to earn $50,000 by the end of the year? And so Harry's earnings, I'm going to make a variable for Harry's earnings. I'm going to make that H. And I would that's going to be equal to $30,000 plus, that says 5%, which is 0.05, commission on sales. So I put sales. And the reason I don't put S is because when you use S as a variable, it looks too much like a 5. So I like using a different letter than S for a variable for that reason. And we know that his earnings, he needs to make $50,000 so I'm going to replace that H with 50,000, and then I got 30,000 here plus 0.05 sales. And then if we subtract 30,000 from both sides of this equation, we have on the left side 20,000, and I'm going to move that over the right side, 20,000. And on the right side we have 0.05 sales. I'm going to write down 0.05 sales. And so we're going to divide by 0.05. Well, I happen to know that 0.05 in fractional form is going to be 1/20th. And if you can think of it this way, that how many nickels does it take to make $1? Well, 20 of them. So that's going to be 1/20th. And if we write this as 1/20th sales is equal to $20,000, what can you do to solve for this? Well, you can just go ahead and multiply this whole equation here by 20, or you can look at it as cross multiplying. So what you get is, just working the right here, sales, the amount of sales Harry has to make is 20 times $20,000, which is going to be $400,000. So that's going to be our correct answer for this one. Next, vocabulary. And then, so we have 6 word choices for 4 blanks. So let's look at this. Blank is the set of second elements in an ordered pair of tables. So if we have an ordered pair like 1, 5, what is this going to be called? And you can almost look back to, well, I guess it'll be the y values, right? It'll be the range. And it's just like that problem we had a little while ago. Okay, blank, a mathematical statement that shows 2 expressions are equivalent. That would be an equation. That was just like that last one we did, right? That'll be an equation. So is equivalent is a fancy way of saying that they are equal. It's an equal sign. Blank, a value for the variable or an ordered pair that makes an equation true. That is going to be a solution. And the last thing here, blank, a relation which every input has exactly one output, that is called a function. That's when we went over that vertical line test. Remember that? That's an example of that. Okay, next. Representing functions as graphs. And so here we have this equation. It says change to slope-intercept form y equals mx plus b. So I'm just going to write this here. Negative 3x plus 3y is equal to 6. And so I say we're going to add or subtract the x term. So we're going to add it here, plus 3x. So we have is 3y equals 6 plus 3x. And now we divide by the coefficient of y, which is 3. So we get y equals, and we have 3 divided by 3. So in slope-intercept form, it's going to be x plus 2. So that's going to be our slope-intercept form. And then, so our y-intercept based on this is going to be 2. And our m is going to be, how many x? 1x. M is 1. And then our x-intercept we get by setting the y equal to 0. So I'm going to bring this up here like this. So I'm going to put 0 equals x plus 2, and subtracting 2, x is equal to negative 2. That's going to be our x-intercept. And said, and also, what are the input points? They say there, yeah, they give us these input points. Use negative 2, negative 1, and so on. So negative 2, negative 1, 0, 1, 2. And for an input of 0, we get an output of our of our y-intercept, which is 2, and then we can just use this function. In fact, we can draw it actually. Our y-intercept is 2. We know our slope is 1, so we go up 1 over 1. So the thing is going to look like this. So something like this. Okay, and then the rest of these, we just add 2 to x. So negative 2 plus 2 is 0. And we see at negative 2 we have our x-intercept. And then we go up 1 every time. Let's see, then 3, 4. 2, 4 is that we have here. Yeah, so this is good. I think we have everything in place. And this is our slope intercept form, which is y equals x plus 2. All right, distributive property. So we have these problems. I'm going to make a little more room here and bring this down a bit. Okay. What we have here is we can distribute our negative 8k to what's inside the parentheses here. So I'm just going to rewrite here as negative 3k cubed plus 8k. And then here we have negative 8k times 6k squared. Well, 6 times 8, I think that's 48. So we're going to have negative 48k cubed. And then we have negative 8k times negative 4. That's going to be plus 32k. And then combining like terms, we have negative 3k cubed minus 48k cubed. That's going to be negative 51k cubed. And then we have 8k plus 32k, so that's going to be plus 40k. So that's going to be that first one worked out. Next we have this one, quantity 3x minus 5 times quantity 2x plus 7. And sometimes you'll see it like this. You see this first outside first outside inside last. I like writing it out like this with a box. To me, just lends more clarity to the situation. So I'm going to put 3x minus 5 over here, and I'm going to put 2x plus 7, and then just multiply the space with the intersect. So we got 6x squared. Then we have negative 5 times 2x, which is going to be negative 10x. And then we have 3x times 7, which is going to be 21x. And then we have negative 5 times 7, which is negative 35. And then we can combine these like terms here for our answer. And for that we get 6x squared. And then we have 21x minus 10x, which is going to be plus 11x. And finally, minus 35. Okay, well, that's it. I hope this was helpful to you. Good luck, and as always, thanks for viewing.